Hello students, welcome to KUTV Elimu Live. We have a lesson in mathematics for Form 4 and we shall be discussing the topic Statistics 2. Being a continuation of what we discussed as regards to Statistics 1, we will be able to look at a few areas that are contained in Statistics 2. And more importantly, we'll be discussing the calculation of mean. So in our lesson today, students, being Form 4 mathematics, Form 4 mathematics, Form 4 mathematics, we are handling a topic we call Statistics 2. Statistics 2. We are handling Statistics 2, and our area of concern today is mean. Our area of concern is mean. Just from Form 2 work, when we discussed Statistics 1, students, we noted that statistics, being a branch of mathematics, has various components and various measures that we analyzed as Statistics 1. And one of the measures that we analyzed in Statistics 1 were what we call the measures of central tendency. And we said the measures of central tendency are three. There is mean, there is mode, and there is median. Those are the things that we analyze as measures of central tendency covered in Form 2. When we get to Form 4, we still look at the three measures of central tendency, however at a different angle, and that is why in our analysis today, when we'll be looking at mean, we will focus so much on what we call determination of mean using what we call an assumed mean. To begin, let's be able first to understand two things. Students, that in statistics, we look at collection of data. Statistics as a branch of mathematics deals with the collection, recording, presentation, and analysis of information. And this information, we refer to it as data. When we collect data in statistics, we record the data in various forms. What are these forms, students? Yes, we record the data based on whether the data has been organized or not. And that is why we mention of two things, what we call grouped data and what we call ungrouped data. We have what we call grouped data and ungrouped data. Who will remind us what we mean by grouped data, students? Good. When talking about grouped data, we mean data that has been organized, data that has been organized, in what we call classes. So we have data organized in classes, students. We refer to it as grouped data. There is the other kind of data that is not organized. We just make the collection and the recording, but there is no more that is done on that particular data that can give it easy analysis and understanding. We refer to it as ungrouped data. Therefore, ungrouped data is simply a set of information or data that has not been organized, in groups we call classes. Therefore, students, up to that point, we should be able to tell that there is a difference between grouped data and ungrouped data. In other cases, we refer to ungrouped data as what we call raw data because we are picking the information from its original or raw form. And so we refer to it again as raw data. Therefore, when we are calculating measures of central tendency and in particular mean, we will need to do an analysis of mean for grouped data and mean for ungrouped data and see what is the distinction between the two sets of data as regards to the calculation of mean. And so we will do an example for each one of them, grouped data and ungrouped data, and then now eventually we will now proceed to the continuation of the calculation of mean, which is what we call the use of assumed mean. So let's look at an example. Let's look at an example of the calculation of mean. Number one, you're told the data below shows masses of newborn babies recorded in a clinic. And the masses are 30. The masses, these are in kgs. We have 30, 36, 35, 32, 33, 36, 38. That is the data that is available for the newborn babies in terms of their masses. And the question is, students, we calculate the mean. And in this case, the mean mass in kgs or in kilograms. You are in a class or you are in an exam, student, and this is the question you've been given to determine the mean. Having looked at it in Form 2, what should be done as to calculation of this kind of mean? Yes, what we do is we obtain the average. We obtain the average mass. So in this case, our mean is the average. So how do we get it, students? Right, we sum them up, 30 plus 36 plus 35 plus 32 plus 33 plus 36 plus 38. Then what do we do, students? We divide by the number of babies. How many babies are there? 1, 2, 3, 4, 5, 6, 7. Good. The new babies that were recorded were 7. I hope my students have a calculator to help us calculate the mean with ease. So take out your calculator, students, and let's do the mean together. We are having 30, so let's have 30 in our calculators, plus 36, plus 35, plus 32, plus 33, plus 36, plus 38. What do you have, students? Right, that is 240. 240. How many babies? 7. Good. Let's go back to our calculators. 240 divided by 7. What's the answer? Good. The answer is 34.29 kilograms. 34.29 kilograms. So we shall have obtained our mean mass. And remember, if the question is to obtain the mean mass and the masses have been given in kilograms, then we expect you to give us the answer with the right units. And the right units in this case are what, students? Yes, they are kilograms. Good. Number 2. In Form 2 as well, we looked at the calculation of mean for what we call grouped data. And we said that if you are calculating mean for a grouped data with the values in consideration being for x, then we get the mean by the sum of fx over the sum of f. The sum of fx over the sum of f. Who will help us understand what this formula and each component represents? Yes, the first component, this sign is called sigma. It is a mathematical sign that represents or that is used to mean sum or add. What about f, students? Good. F represents frequency. F represents frequency. And frequency is the number of times a particular item appears or a particular variable appears in a set of data. So if it appears 10 times, then that is the frequency, f. What is x, students? What is x? Yes. X is the midpoints. X refers to the midpoints. X refers to the midpoints. Good. Now, what are midpoints, students? What are midpoints? Good. Midpoints simply mean the sum of the lower class boundary and the upper class boundary divided by 2. In other words, it is a half of the sum of the lower class boundary and the upper class boundary. That is what we call the midpoints. So we shall say here midpoints equal to the upper plus the lower boundary. Then we divide by what? 2. We divide by 2. And this then becomes our formula for calculating mean for a grouped data. So let's take a look at an example and see how well can we apply this formula in the calculation of mean. How shall we apply the formula in the calculation of mean? Example. Number 1, the table below shows marks scored by Form 2 students in a physics test. And this is our data. This is our table. We have the marks. We have from 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, and 91 to 100. And they are distributed as follows. So number of students. The distribution is as follows. We had 2, we had 7, we had 3, we had 5, we had 10, we had 1, we had 14, we had 6, we had 9, and we had 8. That is the distribution of students as per the scores recorded in a physics test. And so what is the question? The questions are as follows. Part A, we are asked to state the model class. We are asked to state the model class. And part B, we are required to estimate the mean mark. Estimate the mean mark. Those are the two questions that we need to analyze with reference to the data that we have from the Form 2 students who sat for this physics test. The first thing that I want you to remember, students, is the record given as regards to the marks represents what we call the classes. So this is a class of 1 to 10, meaning the number of students who scored between 1 and 10 mark were recorded as 2. Those who scored between 11 and 20 were recorded as 7. Those who scored between 21 and 30 were recorded as 3. Those who scored between 31 and 40 were recorded as 5, and all the way up to the last scores, which were 91 to 100, and we had 8 number of students. When we talk about 1 as a representative of this data, of this class, 1 represents what we call the lower class boundary, and 10 is the upper class boundary. So in simpler terms, what is on the left is the lower class boundary, and what is on the right is what we call the upper class boundary. So if you've been asked to give the model class, what do you consider, students? What do you consider before you give the model class? Yes, you look at the number of students or the frequency. Now, what will make you pick a certain class to be the model class, student? Yes, you look at the number of students and the class. So the class that has the highest frequency is what we call the model class. So we have to examine these frequencies and see which one is the highest. Which one is the highest, students? Good, 14. But why not 8, or why not say 9 to 100, students? Good. It is the highest frequency, not the highest range of scores. If you are to take the highest range of scores, students, you will pick 91 to 100. But in our case, we are looking at the highest number of students recorded in a particular class, and that is 14. Therefore, 14 lies in which class? 61 to 70. That becomes our model class. This becomes our model class. Yes, 61 to 70. That is our model class. And 14 is what we refer to as the model frequency. Good. If you are asked the model frequency, then you will give 14. But if they ask the model class, remember, it is 61 to 70 because these are the classes and these are the frequencies. Good. Number 2, we need to estimate the mean. We need to estimate the mean. And the formula has been given before. We say that mean is equal to the sum of fx over the sum of f. So the procedure for determining mean is quite simple. You have first to be able to identify the midpoints. Identify the midpoints, the column for x. So let's get together. What are the values for x, students? What are the values for x? So you go to your table and you insert the values of x. I have explained to you before that to get the values for x, which are the midpoints, you will need to take the lower class boundary and the upper class boundary, sum them up and divide by 2. That is why we call them midpoints. So it is 1 plus 10. What is it? 11. Divide by 2. What is it, students? Good. It's 5.5. Come to the second class. 11 plus 20 is 31. Divide by 2, that gives us 15.5. And because the difference is the same and these classes have an equal interval, it means the subsequent classes will have an addition of 10, 10, 10. So this will be 25.5, 35.5, 45.5, 55.5, 65.5, 75.5, 85.5, and 95.5. After that class, what is the next thing to be done? Good. We generate the column for fx. F means frequencies times the midpoints. Frequencies times the midpoints. So again, students, let's go to our calculator and do the calculations together. In the first class, it is 2 times 5.5. 2 times 5.5, and that gives us 11. So we record 11. Then 7 times 15.5, that gives us 108.5. 25.5 times 3, that gives us 76.5. 35.5 times 5, that gives us 177.5. 177.5. And then this gives us 455. This remains 55.5. And 14 times 65.5 gives us 917. 6 times 75.5 gives us 453. 9 times 85.5, that gives us 769.5. And lastly, 8 times 95.5, the answer is 764. What is the next step, students? Good. We obtain the sum of fx. We obtain the sum of fx, so we add all these entries. So 769.5, we add 453, add 917, add 55.5, add 455, add 177.5, add 76.5, add 108.5, add 11. And that gives us a total of 3,787.5. 3,787.5. Finally, what is the mean, students? Good. The mean will be sum of fx, which is 3787.5, divided by the sum of frequencies. This is 9, 12, 17, 27, 28, 42, 48, 57, 65. Sum of f is 65. So we divide by 65, students. Divide by 65, that is 3787.5 divided by 65. And our mean is 58.27 marks. 58.27 marks. So if you consider that particular example, you will find that the mean for that particular class was 58.27. And now, we add something to the discussion on mean. We want to add something to the discussion on mean. And in this case, students, I want us to discuss what we call the calculation of mean using an assumed mean. And recall that when we talk about assumed mean, that is a mean using assumed mean, that there will be a situation, students, where you'll be given a question to analyze the mean for a given set of data, but then the examiner gives you a specified value that has been extracted to be an assumption of what we expect to achieve or to obtain as the mean. In that case, we are giving a value that may or may not be the actual value for the mean. So we shall have to know, what do we do when we are given an assumed mean? And first thing will be the assumed mean being applied or being applied to what we call grouped data. And the grouped data is what we've said we have classes or data organized in groups we call classes. So what do we do, students? We now have an assumed mean. Let's call it A to be our value representing the assumed mean. There will be three things that we shall need to do. There will be three things. So given an assumed mean A, to obtain actual mean, which is the mean of X. Step number 1, we shall have to obtain or simply obtain the values of deviations of mean of the assumed mean, deviations of the assumed mean from the midpoints, or simply the values of X. And so we call these deviations, we use either D or T. It depends on what you want to present. So it can be T being X less assumed mean. And number 2, we now obtain the product. We obtain the product of frequencies by the deviations, T, i.e. Ft. And step number 3, students, we shall now obtain or determine the mean of T. That is, the mean of T is the sum of Ft over the sum of F. The sum of Ft over the sum of F. And finally, mean of X. The mean of X becomes the mean of T. We add the assumed mean. The mean of T, we add the assumed mean. This can be represented as the mean of T add the assumed mean. So those are the steps that we shall need to do or to follow as regards to the determination of mean using the assumed mean. Let's put this in practice. Students, let's put this in practice by looking at the following example. Number 1, the table below shows masses in kilograms of Form 1 students taken during their admission during their admission. So during the admission of Form 1 students, we took the following entries as regards to their masses. And these masses are presented in this table. They are presented in this table. So we'll have masses in kilograms, and then we have the number of students. The number of students. We have 40 to 44. 40 to 44. 45 to 49. 50 to 54. 55 to 59. And the entries are 7, 10, 4, and 6. Those are the entries that we had as regards to the number of students. And then you're told using an assumed mean, using an assumed mean of 55, find the actual mean. Find the actual mean mass. Find the actual mean mass. Find the actual mean mass. My student, that is the question that we have, that we need to analyze. We need to analyze and look at how we are going to determine the actual mean. I have given you the steps that we shall follow for each of the parts. But the question that I've given you students has something that we can also learn a new thing. And that is the presentation of the frequency distribution table. That the frequency distribution table could be presented in a vertical form or horizontal form. It all depends on how the student is going to interpret the two. But if you realize that you have a challenge interpreting the horizontal table, horizontal frequency distribution table, we are allowed students to change to the vertical presentation. And therefore, I will restructure the table to be in the vertical form as follows. Our solution. We will take the table in the vertical form and have masses in kilograms against the number of students who constitute to our frequencies. So we have 40 to 44, 45 to 49, 50 to 54, 55 to 59. The entries being 7, 10, 4, and 6. The entries being 7, 10, 4, and 6. In our illustration with the procedure, we've said the first thing to do is to obtain the midpoints. Obtain the midpoints, and that constitutes our column X. So students, take out your calculators and let's make use of the calculators whenever we are doing mathematics. Not because we do not know, but because we want to maintain the highest level of accuracy. So in the column for X, we've said you get it by taking the lower boundary plus the upper boundary, then we divide it by 2. So let's do it together, students. It is 40 plus 44. Then obtain the solution first. That is equal to 84. Then divide it by 2 to get 42. So we shall fill 42 at that point. Take the second entries, that is 45 plus 49, and then we divide it by 2. The answer is 47. And I said because the kind of data we deal with in high school are such that they have a certain level of dependence in regards to the class interval or the class size. They will always be even distributed. Therefore, in this case, if the difference between these two is 5, automatically it means then I will be adding 5 to each of the successive classes to obtain the values of x. So I will have 52 and 57. Step number 2, we need to obtain t, the deviations. So we shall say our t is x minus assumed. X minus assumed. Remember, our assumed is given in the question as 55. So it means 42 minus 55. So we shall take it. 44 minus 55 is negative 11. 47 minus 55 is negative 8. 52 minus 55, it's negative 3. And 57 minus 55, that is 2. Once you obtain t, students, the next step is to obtain ft. ft. Now 7 by negative 11, negative 77. 10 by negative 8 is negative 80. 4 times negative 3, negative 12. 6 times 2, 12. Then we obtain the sum, ft. That will be negative 77 plus negative 80 plus negative 12 plus 12. That gives us a sum of negative 157. A sum of negative 157. Once we have that sum, students, as per our procedure, the next thing will be to obtain the mean of t. To obtain the mean of t, and that is the sum of ft over the sum of f. Sum of ft over the sum of f. So that is the sum. Shall now do 7 plus 10 plus 4 plus 6 to get 27. Therefore, what's the mean of t, students? It's negative 157 over 27. 157 divided by 27, and that gives us negative 5.82 to 2 decimal places. Finally, what is the mean of x? The mean of x, therefore, is the mean of t plus the assumed mean. So negative 5.82 plus 55. Negative 5.82 plus 55, and that gives us 49.18. What were they? They were masses. Therefore, this is kilograms. That is our mean for this particular set of data, applying the concept we call assumed mean. Therefore, in this case, students, for our lesson today, we have discussed 3 important items. We have discussed 3 important items. And these items have been under the topic we call statistics 2, but we derived everything from statistics 1 by discussing first on what we call the measures of central tendency. Measures of central tendency. And we have said that we have 3 measures of central tendency, and that is the mean, the mode, and the median. But for this case, we have discussed the aspect we call the mean. We've discussed the mean. And we've discussed mean based on two sets of data. We've discussed mean based on, number one, grouped data, and number two, based on ungrouped data. And I've said that group data is the set of data where information or the data has been organized in groups we call classes. And grouped data, that data has not been organized in groups we call classes. And we've seen to get the mean for a grouped data, we have applied the formula that mean is equals to sum of fx over sum of f. And we have described each of the components in that formula. Under ungrouped data, we've said that mean is the average. We've said that mean here is the average. Mean is the average, where we sum all the entries given, divide by the number of entries that you've been given, or the number of items. We will get the mean. And I've gone to the extent of describing something not in mean, but co-opted from mod to mean, or to the point we call the model class. And we've said that the model class is simply the class with the highest frequency. The class with the highest frequency. That is called the model class. And then we've gone away from this mean, which you are calling the actual mean, to the discussion of mean using an assumed mean. Mean from. That is the actual mean from assumed mean. Actual mean from assumed mean. Actual mean from assumed mean. And I've said that this actual mean from assumed mean is done in 4 stages. We've highlighted the procedure that number one, you have to identify the values of x, which represent the midpoints. And number two, to identify the deviations of assumed mean from the midpoints, obtain the ft, which is the sum or the product of the deviations and the frequencies, and then get the mean of t. And so we've said that the actual mean equal to actual mean of x equal to the mean of t plus the assumed mean. What is the mean of t? Sum of ft over sum of f plus assumed. That is what we have discussed in our lesson today. Therefore, as a way of practice, students, we will have this question as an assignment and ensure you work it out following all the steps we've highlighted to ensure that you are able to recall the elements we've discussed in our lesson today. So this is a practice question. Practice questions. Number one, calculate the mean for the following set of data. Calculate the mean for the following set of data. And so we have 6, 3, 2, 7, 5, 12, 8, 10, 3, 7, 5. Number two, the table below shows heights in centimeters of seedlings in a nursery. The table below shows heights in centimeters of seedlings in a nursery. So we have the heights in centimeters, then we have the number of seedlings. The number of seedlings. We have the number of seedlings. So we have between 5 to 9, between 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 30. 25 to 30. So these are 6, there are 3, there are 7, 8, then we have 2. We have 2. The questions are as follows. The questions are as follows. Part A, state the model class and the model frequency. State the model class and the model frequency, 2 marks. Number B, estimate the mean height. Estimate the mean height, 3 marks. Estimate the mean height, 3 marks. Number C, using an assumed mean of 25, using an assumed mean of 25, calculate the actual mean, full stop. Hence, that is, calculate the actual mean, full stop. What is the relationship? What is the relationship between the values of mean obtained in B above and C? So we'll have to get the mean and do the comparison to give our final verdict as regards to the relationship between the two sets of mean obtained as in their questions. So that is all we have for you today, students. Until next time, I have been your teacher, Mr. Ndenga Elfas. Goodbye.